All right, so part 2 of 2.1, we're working with the domains of functions. With these functions that you have that have these x squares, automatically you're going to have a domain of all real numbers. You got to think that x squared means that you have a parabola which looks like a U. So on that graph, as it goes up, it continues to go to the right. As it goes up, it continues to also go to the left. So the x values that are being covered are automatically all real numbers. However, you do have specific instances where that will not be the case. So if you have your variable in the denominator, you have to set the denominator not equal to 0 and find what x cannot equal. If the variable is underneath the square root, you set the expression under the square root greater than or equal to 0. If there's a variable under the square root in the denominator, you set the expression under the square root greater than 0. So if it's in the denominator, x is in the denominator, set it not equal to 0. The whole expression, set it not equal to 0, solve for what x cannot equal. If you have an expression that's underneath a radical, set just the expression underneath the radical greater than or equal to 0, and then get x by itself. If there's a denominator that has a square root, take the expression that's underneath the square root in the denominator and set it to where it's greater than 0 and get x by itself. If we look at these 4 examples, for A, we have f of x is equal to 1 over x squared minus x. You have an x in the denominator, so set the denominator not equal to 0 and solve what x can't be. So that denominator is that x squared minus x. It cannot equal 0. You have to factor this in order to solve for x. When you factor it, factor out an x, you're going to have x times x minus 1 is not equal to 0. Set both parts not equal to 0. So x cannot equal 0. X minus 1 cannot equal 0. From here, solve for x on both of them. The one that x is not equal to 0, you can't do anything else with it. But the x minus 1 is not equal to 0. Add the 1 over, and you get that x cannot equal 1. So with this, you need to set yourself up where you have interval notation that represents these. So if x cannot equal 0 and x cannot equal 1, but it can equal any other number from negative infinity to positive infinity, you're going to have that negative infinity up to 1, or up to 0, sorry, not including the 0, so there's going to be a parentheses on there. That's going to be a union with anything between 0 and 1, with a union of anything from 1 to positive infinity. For example B, we have g of x is equal to the square root of 9 minus x squared. So we have a radical. We're going to take what's underneath that radical and set it to where it's greater than or equal to 0. So underneath that radical, we have 9 minus x squared. That's going to be greater than or equal to 0. We're going to move that x squared over by adding it to both sides. And this leaves us with 9 is greater than or equal to x squared. Now, you're going to have to take the square root of both sides. However, when you take the square root of both sides, the square root of that 9 is going to give you a plus or minus 3, but you have to switch that sign on the negative. So I'm going to rewrite this as x squared is less than or equal to 9, and then I'm going to take the square root of both sides. When I take the square root of both sides again, I'm going to rewrite this as 2 separate inequalities. One that's the x is greater than or equal to a negative square root 9, as well as x is less than or equal to the positive square root of 9. The square root of 9 is 3, so this is going to give us x is less than or equal, x is greater than or equal to negative 3, and x is less than or equal to positive 3. These two inequality signs go in towards each other. Our inequality that includes the smaller numbers on the left. So this is an and statement. Write it in interval notation. We're going to have a bracket, -3, comma, +3 with a closed bracket. For example, C, we have h of t is equal to t over the square root of t plus 1. We have a radical in the denominator that has our variable. So we're going to set that expression underneath the radical greater than 0. So t plus 1 is going to be greater than 0. We're going to solve for t here. We're going to subtract the 1 from each side. So t is greater than -1. Again, we're going to put this in interval notation. So we're going to have a parentheses on that -1, comma, infinity with a closed parentheses. For D, we have f of x is equal to 2x squared minus 3x plus 1. We have an expression here that has an x squared. There is no denominator where x is in the denominator. There's no radical either. So automatically, all real numbers is our domain. For a recap from yesterday, we're evaluating these piecewise functions with the indicated value. So we have to just substitute in these values that are in parentheses into those inequalities to see which gives us a true statement. Then we use the expression to the left of that inequality and simplify. So our first one, we have f of 5. If we plug in 5 to each of these inequalities, we got to see which one works. We plug it into the top one. 5 is less than or equal to -2. That's not true. Plug it into the middle one. -2 is less than or equal to 5. That's true. But is 5 less than 1? No. So use the last one. 5 is greater than or equal to 1? Yes. So use the x plus 4. So f of 5 is going to be x plus 4. We're going to take that 5 and plug it in for x. We have f of 5 is equal to 5 plus 4. 5 plus 4 is 9, so f of 5 is equal to 9. For B, we have f of 1/3. So again, plug it into your inequalities, see which one gives you a true statement. Use the top one. Is 1/3 less than or equal to -2? No. Is -2 less than or equal to 1/3? Yes. Is 1/3 also less than 1? Yes. So use the middle one. It's just the 3, so f of 1/3 is just equal to 3. For C, we have f of -9/2. -9/2 is the same thing as -4 1/2. So use each of these inequalities to see which one gives you a true statement. Is -9/2 less than or equal to -2? Yes. So use the 2x squared minus 3. So we're going to take f of -9/2 and plug it in for the 2x squared minus 3. This is going to leave us with f of -9/2 is equal to 2 times -9/2 squared minus 3. The -9/2 squared is going to give us 2 times 81/4 minus 3. The 2 times 81/4 gives us 81/2. Minus 3, which is the same thing as 6/2. So that 81 minus 6, keep it over 2, is going to give us f of -9/2 is equal to 75/2. And you can leave it that 75/2. You do not need to turn it into a mixed number. For D, we're given f of negative 4. So plug it in. Is negative 4 less than or equal to negative 2? Yes. Use the 2x squared minus 3. So f of negative 4 is equal to 2x squared minus 3. We have f of negative 4 is equal to 2 times negative 4 squared minus 3. That negative 4 squared is 16. So f of negative 4 is equal to 2 times 16 minus 3. 2 times 16 gives us 32. So f of negative 4 is equal to 32 minus 3, which gives us f of negative 4 is equal to 29. For your next part, you are using the function to evaluate and simplify. When you're doing this, it depends on what's in the parentheses that you're doing. So if you look at the first example, we have f of x is equal to 3x squared plus 5. You're doing first f of x plus 2. So you're going to literally replace the x with the x plus 2 and then simplify. So we're going to have 3 times x plus 2 squared plus 5. That x plus 2 squared you have to FOIL out. So you can rewrite this as 3 times x plus 2 times x plus 2 plus 5. That x plus 2 times x plus 2 is going to give us 3 times x squared plus 4x plus 4 plus 5. We're going to distribute that 3 to give us 3x squared plus 12x plus 12 plus 5. When we simplify this, we're going to have f of x plus 2 is equal to 3x squared plus 12x plus 17. For our next example, you have f of x plus f of 3. So you're going to take f of x, which is that 3x squared plus 5, and add it to the 3 being plugged in for x. So you're going to have 3 times 3 squared plus 5. Simplify the 3 squared. That's going to give us 3x squared plus 5 plus 3 times 9 plus 5. The 3 times 9 gives us 27, so 3x squared plus 5 plus 27 plus 5. You know 5 plus 5 is 10, so this is the same thing as 3x squared plus 10 plus 27, which gives us f of x plus f of 3 is equal to 3x squared plus 37. So you'll see here is whenever I write my answer, I make sure that I include that first part that I started with, that f of x plus f of 3 is equal to before my solution. For our next example, we're starting with f of x is equal to negative 6x plus 4. We're going to first do f of 2x. So we're plugging in the 2x for x in this negative 6x plus 4. So it's going to be negative 6 times 2x plus 4. The negative 6 times 2x is negative 12x plus 4. And this gives us a final solution of f of 2x is equal to negative 12x plus 4. For the next one, we have 2 times f of x. So you're going to be doing 2 times whatever f of x is, which is that negative 6x plus 4. So you're going to distribute this 2 in. This is going to leave us with 2 times f of x is equal to negative 12x plus 8. For our next example, we have f of x is equal to x minus 3. We're doing f of x squared. With this f of x squared, we're plugging in that x squared for x. So that's just going to be the x squared minus 3.